Okay, dear students, this is the second part of our lesson, units and measurements. From the first part, you got an idea about units, measurements, what are the SI units, like that. Okay, now we are going to discuss how we are measuring length, time and mass, likewise. And you have an idea about the definitions, what is length, what is mass, what is time, like that. Okay, so there are two methods for measuring length, that is direct method and indirect method. The first we can consider the direct method. Direct means directly we are measuring the length by using some equipments. Okay, you know that length is the distance between 2 points. Isn't it? Length is the distance between 2 points. So we are measuring that length. How we can measure? We can use a scale for measurement. So we can measure a distance from 10 raised to minus 3 to 10 raised to 2, means 1 millimeter to 100 meter can be measured by using a meter scale. It is only possible to measure from 1 millimeter to 100 meter, means 10 raised to minus 3 meter to 10 raised to 2 meter. Okay, by using a meter scale we can measure the ranges from 10 raised to minus 3 to 10 raised to 2. That means we can measure the length from 1 millimeter to 100 meters. Okay, like that we can measure. And for measuring more than this 100 meter, we are using some other method. That is not a direct method. There we are using some indirect methods. Okay, then we want to measure the less than this units, means less than 10 raised to minus 3, means 10 raised to minus 4, 10 raised to minus 5, like that. There are some equipments for this, that are, the first one, if we want to measure a quantity with an accuracy 10 raised to minus 4 meter, means less than millimeter. So there we are using a device which is called vernier caliper. The device which is used to measure a length by an accuracy 10 raised to minus 4. That's a direct method. We can use a device. That device is called vernier caliper. This is the device. Whatever we want to measure, we are putting that here. Or if we want to measure any inner radius like that, then we are using this point. Then this is the main scale and this is the vernier scale. So we have some equations to find this values, exact values. So total is equal to MSR, means the main scale reading, plus VSR into LC. Means LC is the shortest value that can be measured by using an equipment. For in the case of scale, the shortest value, the least value, it is 1 millimeter. And likewise, this equipment is also have a least count. Okay, that we will discuss in our next sessions. Okay, least count. Least count is the smallest value that can be measured using an equipment. Okay, it is the smallest value we can measure using an equipment. That is called the least count. Okay, so it has a least count. By using that only we can find the values. We want to do the vernier calipers experiment in our labs. Okay, then just now you want to understand the vernier calipers is a device which is used to measure the accuracy of 10 raised to 4 meter, like that. Then again, if we want to measure the accuracy 10 raised to minus 5 meter, then we are using another device that is called screw gauge. And one more device is there, that is called spirometer. Okay, this is the figure for screw gauge. Screw gauge is also the experiment we want to do in our labs. Okay, screw gauge. So here we can say that we can see some screws. This is the screw. We can adjust by rotating this, and there is a scale which is called pitch scale, and another one it is called circular scale or the head scale. Here only we are putting what the measurements we needed. We can put a wire or anything. So by using this we can measure the accuracy of 10 raised to minus 5. Okay, less than 10 raised to 4 we can measure by using this. Tiny particles are measured by using some other methods. Okay, that we will discuss. Now, the first thing, what is a scale is used to measure the length with an accuracy 10 raised to minus 3 to 10 raised to 2, and a vernier calipers is used to measure with an accuracy 10 raised to minus 4, and a screw gauge or a spirometer is used to measure with an accuracy 10 raised to 5 meters. Okay, then there are some indirect method for finding the largest distance. For finding the largest distance we have some indirect method. We can't measure the length of a star by using a scale. So for that we need some other methods. So that is called the some supplementary methods, or it is called the indirect methods. The best method for measuring such a length or height, we can use the triangulation methods or triangular method. Okay, look at here. You can see a triangle. If ABC, that makes a triangle, and AB is equal to H and CB is equal to X. Okay, likewise, then there is an angle theta. Okay, then from this triangle we can make the tan theta. You have an idea about tan, sine, like that. Sine means, sine is a function, that sine is equal to opposite side by hypotenuse, and cos is adjacent side by hypotenuse. Likewise, tan is opposite by adjacent, opposite side by adjacent, that is sine theta by cos theta. Likewise, from this we can find tan theta. So tan theta is equal to h by x. From this we can find the tan theta. So the tan theta is equal to h by x. So from that we can find h if we want to find the height of a building. So we can find it by using this method. So it is h is equal to x tan theta. Okay, from that triangle only we will get h is equal to x tan theta. This is one method for finding the largest distance. It is an indirect method. It is called the triangular method. So knowing x and theta, the angle, we can find h. Okay, this is one method. And there is another method. This is a very important method. That is parallax method. Parallax method. What is a parallax? Parallax means the parallax is the apparent shift in the position of an object with respect to another. When we shift our eye sidewise, the closer object always appears to move in the direction opposite to that of our eye. That means if we are looking this pen, this is a pen, then I close one eye and just I can see this, and again I close this one. There is a small shift I can notice. Okay, that shift is called parallax. Okay, when we are closing one eye, we can see the object, and again I open this eye and I closed this one. Then from that we can see a difference, a small difference. That shift is called parallax method. That shift is called parallax method. Likewise this. Okay, so this is our left eye and this is our right eye, like that. If look at the pen first by left eye, like that. This is my left eye. So I'm closing my right eye, like I can see this object. Then again I'm closing my left eye and looking through right eye. So I can see this object. So that is the object. So there makes an angle. So actually this object is here, and from due to my observations there makes an angle. So I am observing from here and here. So this angle means this angle is called theta, and that angle is actually called it as parallax angle or the parallactic angle. Okay, the distance between 2 points of observations. This is my observation point. This is also the observation point. So the distance between two observation points is called the base. Means this distance or this one, left to right distance, is called base. Okay, then the distance LR equal to B, and between two eyes is the base is angle LOR. The angle made with this observations is theta. That is called parallax angle. Okay, that is called the parallax angle or parallactic angle. This observation points, the distance between these observations points are called base, and the angle is called parallax angle or parallactic angle. Okay, clear. This is one method for finding the largest distance, parallax method. Okay, parallax means it is the apparent shift in the position of an object with respect to another when we shift our eye sidewise. Likewise also, if we are moving our eye from one side to other side, then also there is a shift occurs. The closer object always appears to move in the direction opposite to that of our eye. So that change, that shifting is called parallax. So this is an extension of this. Then the angle made with that parallax method is called parallax angle or parallactic angle. And the observation distance between the observations points are called the base. Okay, by using this we can find the distance of moon or any planet by using this method. So for that we want to consider 2 points on earth. Just I can consider 2 points on earth, A and B. From that point we are observing a planet. Okay, so here we consider the distance S of the moon or far away from planet P. We observe it simultaneously from two different positions, means observations A and B from the earth. Okay, that distance is B. So we select the distant star S dash whose position and direction can be taken up approximately same from A and B. We are taking likewise 2 stars or anyone. So their distance is approximately same. So their angles, okay, like that you can see here. One observation point A and another one B. Okay, this is the planet. I consider this is the planet, and from this point to this point I consider S. Okay, due to the shifting of position, or I consider another one having S dash. Okay, or I am looking from this point to this planet. So this is the distance S. Or here another star, that is S dash. From this A to this S dash is the same distance, and likewise this also. Okay, then we will get this angle and this angle. Due to that we can find this and this opposite angles. This is phi 1, then this is also phi 1. Likewise we can find. This is a triangle and this is also a similar triangle. So this, if it is phi 1, then it is also phi 1. Likewise this, if it is phi 2, then it is also phi 2. Okay, then this total angle is taken to be theta. That is our parallactic angle. Okay, we already studied in the place, means in the plane angle. the distance, if it is an arc, a smaller arc, it forms an arc, so it's just like a plane angle, then this distance by using this theta, it is phi 1 plus phi 2, or it is taken to be theta. That theta is equal to what? This distance by this, isn't it? Arc by radius relation. So now theta is equal to arc by radius. So we will get B by S. B is the base and S is the distance from this point to this, means from the earth to the planet, that is the distance. So we want to find this distance. We know the base distance and we have to find this theta also. Then we will get the distance S, that is S is equal to B by theta. That is that we will get from our arc radius relation. Okay, so that is S is equal to B by theta. This is from the arc radius relation. Okay, so this is the method for finding the distance between two planets, or distance of the moon or any planets. We can use this method. Okay, clear? The equation is S is equal to B by theta. Sometimes these variables may be changes. Instead of S we can use D, or instead of theta we can use alpha. Likewise it will change. Okay, so the equation is S is equal to B by theta, or just we want to know this relation theta is equal to arc by radius. From that relation we can find this. Okay, also by using this method we can find the diameter of other planets. Okay, that we will discuss. Okay, our next topic, how we are finding the diameter of a planet, size of a planet or angular diameter of a planet. Okay, so for that we want to observe that planet from one point. Okay, if this is a planet or moon, like this. So I am observing that object from the point E, and I observe the distance A here, means I am observing from here to this point, means diametrically observing. So this is a diametrical point A, and the opposite side it is B. Okay, so these two distances approximately equals because it is a large distance. So it should be approximately equal, and it is equal to the distance from the center to this. So that is denoted as S. Okay, so if we know this S and we can observe this theta. Okay, we can observe this theta. So by observing that we can find the relation, that is theta is equal to D by D, that is the arc radius relation, means the angle is equal to, plane angle is equal to arc by radius. This radius is observed as this one, that is the distance it is taken to be, that is S, means this one, this is the radius. Like we can observe. So it is taken to be an arc or a circle. So this is the radius. So likewise this S is taken to be the radius and D is the diameter. So we can find, using this equation we can find this D. Theta is equal to D by D. D is the diameter. If knowing S and theta we can find this D. Here this theta angle not in degree, that is in radian. Okay. Radian degree conversion I will take after this. Okay, and also we want to solve some problems using this equations. Okay, so our next topic, now we are going to discuss about the measurement of the small distance. For the small distance we have some direct methods and also some indirect methods. We can use an light microscope or optical microscope for finding the distance or the length of 4000 Armstrong to 7000 Armstrong. That is the wavelength of light 4000 Armstrong to 7,000 Armstrong is the wavelength of light. That range object can be measured by using a light microscope or optical microscope. And the object which having the order 0.6 Armstrong, that we can find by using an electron microscope. This 0.6 Armstrong is the wavelength of an electron. Okay, for finding the order of the 0.6 Armstrong, we can find by using electron microscope. So electron microscope is the device that used to measure the distance of the order 0.6 Armstrong, and the optical microscope is the device that used to measure the distance of the order 4,000 Armstrong to 7,000 Armstrong. Okay, apart from this, there are many methods. Avogadro method, thin film method, like that. Or by using the laser also we can find the smallest distance, means the size of the particle, like that. Okay, these are the methods we can use. So you want to know these two methods very well, and others just read it. Okay. So orders of the magnitude of the length, that is in the universe, the smallest one we consider to be the radius of the proton. It is of the order 10 raised to minus 15, and the largest one, that is of the order 10 raised to 26. That is the distance to the boundary of observable units. Hence it is the boundary of our observable units. You want to go through this table, I will give this table as a note. Okay, you just go through this table. Radius of proton, size of atoms, size of hydrogen atom, size of typical virus, etc. Okay, you just go through it. And next one, mass and weight. What is the difference between mass and weight? Mass is the amount of matter, or quantity of matter contained in an object. Mass of a body is the quantity of matter contained in an object. Okay, matter. For Malayalam it says pindam, matter. Okay, matter contained in an object. So its basic property of matter, it's not depend on temperature, pressure, etc. That is not depends on temperature, pressure, or any variables. Okay, and its unit is kg, that we already discussed. Then weight of a body, which depends on the gravitational pull. So that the weight of the body is equal to mass into acceleration due to gravity. Mass into acceleration due to gravity. That is the weight. That is the change. Mass is m itself and weight is m into g. Okay, so that is the difference. The unit of mass is kg and the unit of this weight is Newton. Okay. So there are also some differences that is mentioned here. Mass is the measure of inertia. Inertia. Do you have any idea about inertia? Inertia means the inability of a body to change its state of rest or uniform motion by itself. Inability. Or we can say that any object having a tendency to retain its state of rest or uniform motion, that is called inertia. Okay, so it is mass is the measure of inertia, but weight is the measure of gravity. Gravity. Okay, and it is a scalar quantity. Mass is a scalar quantity, but weight is a vector quantity. I hope that you have an idea about vectors and scalars. Vector means a quantity having the magnitude and a direction. Likewise, I am going to school. by this direction, if I am specifying, then it is vector. If I am not specifying, then it is magnitude of, means I say it's 2 kilometer. So you can understand the distance is 2 kilometer. If I say the 2 kilometer from here to that point directly, or I say east, from here to east direction there is 2 kilometers. So then direction is there. Here to the west direction, then it is 2 kilometers. That is also direction. Here to here, from here there it is 2 kilometers. There is no direction is specified. So if I am specifying a direction, then it is vector. If there is no direction in it, then it is scalar. Or we can say that the shortest distance called displacement. Displacement is a vector quantity. Distance is not a vector quantity. Okay, likewise. So here this mass is a scalar quantity and weight is a vector quantity. It is a constant quantity. Mass is a constant quantity because mass of a body will not change, but the weight of the body will not change because of the gravitational constant. The gravitational constant, the value of gravitational constant may be changes, and it cannot be zero for a body. Mass cannot be zero, but weight may be zero. At the center of Earth, the weight is 0, but mass cannot be 0. And it is an essential property of material bodies, but it is not an essential property. And it is not affected by the presence of other bodies. The mass is not affected by the presence of other bodies, but it is affected by the presence of other body. Weight may be changes by the presence of another bodies. And its units are gram, kilogram, etc. And likewise, the unit of weight is dyne, Newton, etc. Okay, clear? That is the difference between weight, mass and weight. So, we want to measure the weights by using two methods. First one is the inertial method. Inertial mass and gravitational masses are there. So, inertial case, the inertial mass, the mass of a body which determines its inertia in translatory motion is called the inertial mass. So, inertial mass, translatory means nirangunna, by moving through a plane. Likewise, translation. So, translation motion, it depends on the translation motion. So, inertia, how we are finding this inertial motion? By using the Newton's law, we can find it. So, from the Newton's second law, we know that F is equal to ma, isn't it? Force is equal to mass into acceleration. By using that, we will get F is equal to MIA. I means it is inertial mass. It represents inertial mass. From that, we will get F by A. This mass is called inertial mass of a body, which can be measured by using a inertial balance. It can be measured by using an inertial balance. Like means the common balance, we can measure the mass. Okay. So, inertial mass, the mass of a body which determines its inertia in translatory motion is called its inertial mass. It is defined by Newton's second law of motion, and it is equal to the ratio of external force applied on the body to the acceleration produced on, that is F by A. Okay. Likewise, we can find the gravitational mass also. The mass of a body which determines the gravitational pull acting upon it due to the earth is called its gravitational mass. Gravitational pulls. Okay, every object attracts each other, and also earth attracts every object to its center. There is a pull. So that pull depends the gravitational mass. Okay, so it is defined as Newton's law of gravitation. You have an idea about that. F is equal to gmm by r square. So likewise we can find. So according to this, the force of gravity of earth of a body of mass mg is given by F is equal to g by r square. Here we put for small m is g. For denoting it as gravitational mass. So from that we will get mg is equal to fr square by gm. Just r, put r here and gm here. So it is fr square by gm. So this mg is the gravitational mass of a body which can be measured by using physical balance. That can be measured by using the physical balance. Okay, that's the difference. Then order of magnitude of mass. This also you just go through the table. I will give the table. So here you can see electron 10 raised to minus 30, proton 10 raised to minus 27, uranium atom 10 raised to minus 25, like that. Observable unit 10 raised to, universities 10 raised to 55. So the range is from 10 raised to minus 30 to 10 raised to 55. Okay, then the next one, measurement of time. You have an idea about the time. What is time? That we already discussed. So, measurement of time, according to Einstein, he told that time is simply what a clock reads. It is not a clock reads, what a clock reads. So, any phenomenon that repeats itself after equal intervals of time can be used as time standard. Means time is not simply the clock shows. We can standardize the time with anything that periodically doing or periodically happens. Okay, so some examples are here. Beating of human hearts, that's a period. If it disturbs, the man will go. Okay. So oscillations of the pendulum. That's oscillation also periodic. Rotation of earth about its own axis. Same period. And revolution of the earth around the sun. That's also in the same period. Vibrations of the quartz crystals in quartz wristwatch. That's also in a same period. And period of vibration of cesium-133 atom. That all are the standardized one. So, but we are using this one, period of vibration of cesium atom, that we already discussed. Okay. So, the period of oscillation of cesium atom serves as the most accurate standard time. Okay. Then what are the advantages? Cesium atomic clock has a high accuracy of 1 part in 10 raised to 13. Okay. It can be easily reproduced in any good laboratory. That's also the advantage. And it is not affected by physical conditions of pressure, temperature, etc. That's why we are standardizing by using cesium atom. Cesium-133 atom. Okay. And here also some time intervals are there. That also you want to go through. That is life of most unstable particle. It is 10 raised to minus 24. Like that. The last one. Okay. Period of revolution of the life of the most stable particle is 10 raised to minus 24, and the last one, it is what? Age of universe, it is 10 raised to 17. Likewise, we can calculate the time. Okay, these are the length measurement, mass measurement and the time measurements. I hope that you understand this. Okay, now we are moving to our problem part. Okay, we can directly go to our questions. The first question, we want to convert degrees into radian. We want to find the values for 1 degree is equal to how many radian. And 1 minute is equal to dash radian. And 1 second is equal to dash radian. That we want to find out. Okay, how we can find out that? For that, we can consider a condition that we have 360 degree. What is 360? It's the angle of circle, we can say that. 360 degree, complete rotation. So that 360 degree is equal to 2 pi radian. Is a definition. 360 degrees equal to 2 pi radian. By using this, we can find the value of 1 degree, 1 minute, 1 second, like that. So how we can find 1 degree first? So here 360 degrees equal to 2 pi radian. So we want to get 1 degree. What we can do? Just we can divide this equation by 360. So we will get 1 degree is equal to 2 pi by 360 radian. Okay. So that's equal to pi by 180. Okay. So 1 degree is equal to pi by 180 radian. Isn't it? So this is the value of 1 degree. Or we can calculate this 3.14 by 180. You will get an exact value that you can calculate. Okay. And then, so 1 degree is equal to pi by 180. 1 degree is equal to pi by 180 radian. 1 degree is equal to pi by 180 radian. Then from this we want to find 1 second. How we will get 1 second? For that we have 1 degree is equal to, sorry, 1 second, not 1 second, 1 minute. We have 1 degree is equal to 60 seconds. We have 1. Sorry, next we want to find the value of 1 minute. So for that we have 1 degree is equal to pi by 180 radian. Okay, so we know that 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. So we can write 60 minutes is equal to pi by 180 radian. Okay. So by getting this we will get the value of 1 minute. How? We can divide this equation by 60. So 1 minute is equal to 1 by 60 into pi by 180 radian. You can find the exact value by giving the value for pi and calculating it. We will get the exact value. Okay. So this is the value for 1 minute. Okay. Now we want to find the value of 1 second. So we have 1 minute is equal to 1 by 60 into pi by 180 radian. Okay. Now we want to find out 1 second. So 1 minute is equal to 60 seconds. So for that we can write 60 seconds is equal to 1 by 60 into pi by 180 radian. So for getting 1 second, what we can do? We can divide this equation by 60 again. So we will get 1 second is equal to 1 by 60 into 60 into pi by 180 radian, or that is equal to 1 by 3600 into pi by 180 radian. Okay, so you can calculate that and you will get the exact value. So we got 1 degree is equal to pi by 180 radian, and 1 minute is equal to 1 by 60 into pi by 180 radian, and 1 second is equal to 1 by 3600 into pi by 180 radian. Okay, this you want to by heart because you want to use this in many problems. Okay, so you want to know 1 degree, what is 1 degree, and you want to know what is 1 minute and what is 1 second. Likewise you want to understand. So 1 degree is equal to pi by 180 radian, and 1 minute is equal to 1 by 60 into pi by 180 radian, when 1 second is equal to 1 by 3600 into pi by 180 radian. Okay, or you can calculate this and you will get the exact value. Okay, or just just you by heart this. Okay, clear? Okay, this is our question. The moon is observed from two diametrically opposite points A and B on the earth. The angle theta suspended at the moon by the two diametrically observations is 1 degree 54 minute. Given the diameter of the earth to be 1.276 into 10 raised to 7 meter. Compute the distance of the moon from the earth. That's our question. How we can find it? Just look at. Okay, we are considering like this. We considered that this is the 2 points A and B. This we consider A, this is B. Okay, and here the moon is there. We want to find what? The distance from here to here. Okay, so simply put it as S. We want to find S, and we know the value of B, this distance, and also we know theta. Theta equal to, given it is 1 degree 54 minute. Okay, and also B equal to 1.276 into 10 raised to 7. Okay, these are the values we got. So we want to find out what is the value of S that we want to find out. We know the arc radius relation. What is that? Theta equal to B by S. Likewise we can consider B by S. Okay, for that first we want to convert the value of theta in radian, because that is given in minute and degree. So 1 degree 54 minutes. So we can convert first that we can convert that into completely into degree, like that. Minute. So that theta equal to, we know that 1 degree is equal to 60 minutes. So 60 plus 54 minutes. So it is 114 minute. So now we want to convert this value into radian. So that is into minute. So we can multiply it with that values. That is, we can multiply it with 114, that is in degree. So how we can convert, that is in minute, how we can convert that? So for that we have some relations. 1 degree is equal to pi by 180 radian. So 1 minute is equal to, what is that? Yes, it is pi by 180 into, again there is a 1 by 60 is the. Likewise we want to convert. Okay, or again we can convert this into second also. So if we are converting this into second means then 114 minute again into second, then we want to calculate it. Okay, so if it is a second conversion, then we want to multiply it again with the 1 by 60. So likewise we want to do that. Okay, so then it is like this. Then what so then we want to the value of s. S is equal to b by theta. So what we will get? Just like 1.276 into 10 raised to 7 by 114 into pi by 180 into 1 by 60. Okay, that you can solve and you will get the answer. Okay, or you can also you can multiply it with any other values, like you can multiply it with an exact value. Means if we are giving the value of 3.14, pi is equal to 3.14 by 180 into 1 by 60. Okay, likewise also you can do. Okay, so its answer, you will get the answer is 3.84. For this you will get the answer 3.84. Okay, if you are multiplying, here it's done like the conversion to second, and then it is the actual value, that is 1 by 3600 into pi by 180, that it shows. That's the value 4.85 into 10 raised to minus 6. From that you will get the value. Okay, again the final value you will get like this. Okay. So this is 3.84 into 10 raised to 8 meter. So that conversion is needed. Okay, clear? Okay, then we can move to the next question. Our next question, the angular diameter of the sun is 1920 second. If the distance of the sun from the earth is 1.5 into 10 raised to 11 meter, what is the linear diameter of the sun? We want to find out the linear diameter of the sun. How we can find out? Okay, likewise we can consider. Here just like this. We want to find out this diameter. Okay, so what are the given things? It is, we have that angle, that it is theta. We have theta is equal to 1920 seconds. Okay, and also we have the distance of the sun from the earth, that it is 1.5 into 10 raised to 11 meter. This distance, radius. Here also we can use that arc radius relation, theta, and if the distance is taken to be s and here the diameter it is d, then theta equal to what? Theta equal to d by s. Then d equal to theta into s. Okay, here also the conversion is needed. So we want to convert that. Okay, how we can convert? First thing, we want to convert this theta, that is 1920 second into radian. So that is 1920 into, how we can convert that? We can multiply that with the value. Okay, we have that value. What are they? 1 by 3600 into pi by 180. Okay, so after that we can directly multiply. So so that value d is equal to 1920 into 1 by 3600 into pi by 180 into 1.5 into 10 raised to 11. Okay, so we will get the exact value. So this is the answer. You can calculate it. Okay, then the exact value for this is 1.4 into 10 raised to 9 meter. Okay, here the conversions like it is multiplied with that complete exact value. Okay, so the answer is 1.4 into 10 raised to 9 meter. By using a calculator, you can calculate it. Okay, so these are the problems related to our topics. So this part 2 is over. So next part we can discuss other topics. Okay, clear? Thank you.